So with that, I'm going to go ahead and introduce again our speaker. Cyrus has had 30 years of experience conceptualizing, engineering, and prototyping, and transitioning products into production. And he's worked in telecommunications and with large companies and even startups, and has worked with MEIA companies. And so he has a bio inside the invite if you'd like to read it. But with that, I'm going to turn it over. And please, if you have questions as we move along, you can raise your hand or speak up. Cyrus is okay with people asking questions. We want this to be interactive. And so, Cyrus, take it away with RPM Tech.
Sure. Thank you, Mike and Wade, for setting this up. I really appreciate it. And just to clarify, we have been working with Living Canopies and Brightwaves on getting some proposals together and trying to help them refine their process all the way to manufacturing. So it's a work in progress, and that's pretty typical of what we do. So as Wade mentioned, I'm basically, I consider myself a product development expert / system engineer. I've been involved with all types of product development, from defense, telecom, to med tech, to consumer products, and a bunch of green tech, and I'll share some of my experiences. I have a bunch of slides. I'm going to try to skip through a lot of the minutiae and try to spend more time on lessons learned, and please do ask questions as we go through the process. I love hardware, I love manufacturing, and it's ultimately how all of you are going to get revenue and ultimately profits when you develop your products. So let me share my screen now. Let's see. Share screen. So I'll share the whole screen, and let's go into presentation mode. Let's see. Very good. So I'm going to minimize this. So I started my business 17 years ago, and the idea was really to be able to help companies innovate, solve problems, prototype, and then ultimately transition to production. That is really where all of the revenue comes from, and the profits. Hardware is a necessary part of the overall technology that we live with on a daily basis. Our group includes system engineers, electrical engineers, mechanical, software, firmware engineers, industrial design. We also have model makers, we do fabrication, we have technicians, and we basically help companies go all the way to production. I won't spend too much time on this slide. You can actually see it on our website as well. But really, the most important part of what this slide says, it says that the design process is iterative, and it's going to take multiple steps sometimes to get through all the way to production. You may have a great concept, you design the concept, you prototype it, and you find out that maybe there's a customer feedback that tells you want to do it differently, or maybe some design changes or some improvements that are needed for whatever reason. And you'll see that there's very often this loop back where certain steps are duplicated. The physical product development, unlike software, requires a much larger investment. That includes a team of experts. It includes equipment, a lot of equipment. It requires a lot of space. And ultimately, it is something that requires, again, a very large investment. So the most important part of product development is the phase that everyone really needs to start with and refine, which is understanding what your market is and understanding how you're going to sell your product. We have been involved in a lot of different designs that were brilliant, engineers, entrepreneurs, inventors that came up with really great ideas, but there wasn't a market for that. And it's really important that that gets defined upfront. The point of this is that you have to plan. It's the most important part of the process. The less planning you do, the less prepared you are, the more likely you are to repeat the design processes, to repeat demonstrations with customers, and to go back to the drawing board because you don't understand the market well enough. I'm also always worried about people who talk about selling their product on Amazon or in Walmart, because those are not easy to do. Amazon, if you design a solar panel, for example, that's what you see on the top right. Type solar panel on Amazon, you'll probably have 1,000 or 1,200 or 1,500 items that pop out. So you need to differentiate yourself, and that's expensive and takes quite a bit of work. Same is true of going to Walmart. Walmart's not interested that you can make 5 or 6 or 7,000 units. They're looking for millions, and they have to be ready as soon as they get a purchase order to you. So that is extremely expensive. So what I tell people is spend the time now to plan correctly. The planning includes product, specifications, everything that you can think of in the process. And then, everything else we'll discuss a little bit more details, but ultimately that early product definition phase is very critical. The detailed design phase is really the next one. There's quite a bit of time spent on CAD modeling, simulation, there's component research, there's coding, there's obviously prototyping. And again, once the prototyping is done, there's going to be some updates to the design. There may be some documentation changes or some cleanup necessary. You go through the testing, validation, verification. And the next step is to start looking at sourcing. So most products have custom components in them. They may be molded parts, they may be circuit boards, they may be cast parts. All of these have to be sourced. You work through this with manufacturers as well as distributors for the standard components. And I'll mention that standard components, just because you design a standard component doesn't mean it's available. If you design something and it's very specific to that design and it's not available, like for example, in the last 3 years, we have had to change board designs because certain components disappeared. That is a key point of it. The manufacturing process, typically, most startups do not assemble their own units. I know a couple of startups that have set up production lines, a couple of our customers, but in most cases they buy from contract manufacturer. It's a big item to consider. And if you're going to manufacture yourself, you also have to make a decision if you're going to buy or select the components. Another expensive part of the process is tooling. And we're talking about anywhere between a few thousand to $500,000 worth of tooling could be purchased depending on the product, the size, what you're trying to achieve, the complexity, the number of components. And then ultimately there's all of the testing that's needed. And last step is everything related to the assembly, the basic manufacturing, packing, and shipping. So the point of those slides, like I'll gladly spend some more time if anybody has any questions on this. But the point of these slides is to tell you this is going to take some time. It's a lengthy process. I saw a couple of names I recognize in this session that can tell you how long some things can certainly take. The exciting part, though, is this is really when you are able to finally have revenue. Any questions on the process so far? All right, I'll skip to the next one then. So what do you do at the beginning when you're in the early phases of a development and you're trying to basically make some progress, but you're doing this on a very, very tight budget? Everybody does the same thing. Everybody does bootstrapping. They ask their friends to help them. They ask people that they know. They give a little piece of their business so that the work can be done for free. So there's a lot of things that are done up front. And those things are all going to be related to everything that is related to risk assessment and proof of concept. There's no reason to do industrial design if you don't know that your concept works. It's great, you have pretty images, but it's not going to buy you anything. Now, there may be a reason to have some concept renderings, but that is going to be something that is probably going to be a lower priority. So what I always tell people is you want to assess the risks upfront. and really work on those areas first before spending a lot of time on things. You want to identify what's really important before you start any effort. I'm sure you've heard this before, minimum viable product is a key item here. I tell people all the time, when you're developing a new project, a new product, a new idea, a new company, you want to know what you're going to develop in the long run. You want to consider all of these improvements over the long run, having a roadmap of all of the products you can develop. But what you need to do is you need to focus on what you can sell today at the most efficient cost possible. Prototyping any subsection of the design needs to be verified. For example, we have a customer working on a recycling piece of equipment, and there is a high risk in a separation portion of the design. A lot of the other things are kind of understood, so we focused on that specifically. Use off-the-shelf components whenever you can. So this product on the bottom right is related to a medical device that we designed, and part of the issue we had was we needed to verify the long-term reliability. We did not have the circuit boards available, so we used a bunch of Arduino boards, a bunch of motor controllers, and ran over 100,000 cycles to make sure that the reliability of that instrument was going to be good enough for the requirements. You want to also look at the ability potentially of testing the variability if this is something that's a concern, that's a risk. Because you made one work doesn't mean that's going to work a second time. Maybe you're concerned about temperature, maybe you're concerned about variables in chemistry, or anything else that could potentially impact the variability of the results that you're looking for. There are some cases where you need custom designs. We've done injection molded parts, for example, because there was a biocompatibility problem. We have laid out custom boards to verify the design because our customer was looking for a very small design. Those are the things you want to consider. I mentioned the artist renderings. That's always good to have. Not a requirement, but sometimes when you're going in front of a investor, you may want to have something that represents what you're trying to show. So all of these things have to be considered. Just as a side note, this left prototype here uses a Raspberry Pi. We did a quick and dirty printed part to test a material called electroactive polymer. It's pretty neat material that I'll discuss a little bit more. And we wanted to see if we could use it to estimate the risk of someone falling. This was for a medical application. So examples, bottom right, breadboard. No need to do a full board design if a breadboard is good enough. We have a little Arduino, we've got some solder wires, some components, and that was good enough for what we needed. This one is a little bit different. A non-technical person came to us with a prototype idea, and we went through and figured out how this may look like in a design. There are applications where a customer is looking for something that looks a little bit better quality. So in this case, a customer came to us with this pretty ugly, simple machine unit, and we went through and looked at how to give a branding look to it just to improve it. There are some cases where the design is not manufacturable. In this case here, if you can see my mouse, this was a very cool concept, great idea, but not manufacturable. So I had to go back and be redesigned. And then there's other examples that I can go over in more details if anybody's interested. So these are all other examples. I'm trying to see if there's anything of value here. Bottom right corner, a concept for in vitro diagnostics instrument, which turned out to look very different to those. But this was important for the team to understand what this design may look like. And then this is a custom rendering that we did of an actual product that we have prototyped because the customer is trying to have an announcement online.
Tell us about the canine surveillance system. Did you have to bring dogs in to test those?
Yes, yeah, that's a good one. So this is a customer came to us and they wanted to combine electronics for surveillance on a next generation product. The original product was mounted on top of the back of a dog, and it was extremely uncomfortable. I'm hearing somebody in the background. I don't know if there's someone's microphone's on. But yeah, this was a product that we went to verify that the product was going to be comfortable on the back of the dog for long durations. Just quick and dirty. The actual, I'll show you what the final product looked like. It was pretty cool. So talking about green tech, this is a pretty neat product. So there's a material called electroactive polymer. It may also be known as an artificial muscle. It's a metallized polymer that a customer in Denmark came to us to help them with the electronics. The idea was to convert the mechanical energy from waves and convert it into an actual electricity, basically. And this is a full turnkey product where we had software development, firmware development for the FPGA that controlled everything, custom coils, custom circuit board, the full system architecture. It's a very big project. Took I think almost it took 2.5 years to get the prototype into test because the customer was going through and evaluating the materials that they had. We had to actually go through and figure out how the material is going to respond to the mechanical energy, which is what this jig looks like. And you know, in the end, we basically delivered 10 sets of units that have been testing for about 7-8 years when they stopped the project for a variety of reasons. We've been doing some work with a local company on water quality sensor. This system incorporates some custom mechanicals, optics, firmware. There's software through an app that interfaces to the cloud. In this case, this is not manufacturable. This is just a prototype proof of concept. And to give you an idea how designs change, this P1 here is the original prototype, and it was converted into the next version, which is the P2. We've got a bunch of units that have been assembled and tested by kids from kindergarten all the way to college students. Proof of concept. This is not manufacturable as is. This was just to see if there is enough interest from a potential market, and there is. Other examples of projects, we've done some work on bioreactors, quite a bit of work in the area of managing energy consumption through industrial design, industrial controls. We've done some work with VOCs, measuring the presence of VOCs in the ground with a local company. Some interesting eco-friendly water filtration system, as well as agriculture sensor for sensor and that senses temperature and humidity in the ground. The solar-based charging platform is purely a proof of concept demonstration that we developed for demonstrations, and a bunch of other projects. So back to the lessons learned, you know, going through those slides and talking about the things that I've seen in the past that have resulted in issues. The first one is very important to spend time on IP and competitive analysis of the market. We have had many people come to us with ideas that they thought were patentable, but a quick search identified that it was not the case. And we've also identified potential competition for them. And the reason we do that is, even though it takes time for us to go through this, we just don't want you to spend your money on something that is either not viable from a competitive standpoint, because it's always hard to compete with people that are already in the market, and it's also difficult and just having a patent application doesn't mean that you are actually you own that intellectual property. So that's a big item. The other one is the question about bootstrapping, as I mentioned before, which is I'm pretty sure that everybody here on the call, or almost everybody here on the call, has a technical background. Engineers, scientists, entrepreneurs tend to be very smart and very capable and know how to do everything. And the problem is, that's great. As a mechanical engineer, I can tell you that I've done board layout, I've done coding, I've done fabrication. I can use a bunch of the tools that we have at the shop. But is that where you should be spending your time? There's a point where the bootstrapping hurts because the time to market is so much more important. So this balance between not spending funds too early and waiting too long to get started is another big place where I've seen issues in the process. And then another one I will mention, just as a side note, is coachability. Again, the people on the call, I'm sure, are all extremely bright, but I would highly recommend that you listen to the people that are around you. There's a reason they'll tell you, they'll give you feedback and comments on your designs and ideas.
Hey, Cyrus, we have one question from Sina.
Sure.
Thank you very much, Cyrus. I have two questions here. So one is that you were talking about using off-the-shelf development kits. And by the way, my product is in software, not hardware, but I'm having some similar issues. So the first question is that if we use off-the-shelf, let's say models or some items that has already been developed by, let's say, national labs or university research centers, in our prototype, wouldn't that reduce our capability in the face of the customer that we are not able to do better job?
Sure. That's a fair question. So the short answer is half of it is how you sell it, and the other half of it is how usable it is in the future. So what differentiates your product? If your differentiation is on the software, that software can reside on developer kits are available. So I'll give you an example. This product here, I won't mention the specific processor we use, but let's say we use processor ABC. There is a developer kit from this company that has the processor ABC, that has a driver for the screen that you can see, that has Ethernet and Bluetooth, and allows us to put together a demonstration unit while retaining 100% of the software we've developed. Once we do a custom board of this design, we're going to use the same processor, which means the code is going to be unaffected. Obviously, the porting may need some drivers that may be a little bit different because of specific components, but just in general, it'll be the same. I don't know if you can share what your product is, but maybe some generalities, maybe that we can discuss more in detail of what exactly that is.
Sure. Do you want to discuss it now or after your presentation?
Well, I think if it's a good example for everyone, maybe we should we can quickly go over it, and I think we've got plenty of time for everybody else to ask questions too.
Sure, absolutely. So what we are developing right now is a software platform leveraging AI, advanced analytics, and IoT to not only integrate smart equipments and distributed energy resources across a building or multiple buildings together in just one place, but intelligently match supply and demand of electricity to basically optimize the energy consumption or carbon emission reduction or self-sufficiency.
Sure.
So
Yes. Go ahead.
yes, so part of this process is basically predicting the supply or demand of different equipments, or for example, a solar panel or an EV charger or battery storage. So some of these models have currently been developed, by some national labs. They can certainly be improved. There is no, the best model in the world, but we're trying basically to use some of these models in our prototype. But we were wondering if that would, disqualify us to be a great product in the market.
Sure. So first things first, I'm not an investor, so I'm gonna talk as having been on the other side where, being involved with raising funds for a couple of startups. But at a high level, as a software company, I would stay out of hardware, just because unless you really need it, unless there's a reason to have hardware, your IP is in the software. And if anything, as long as you have, if in order for you to sell your software, as long as you don't need custom hardware, I wouldn't do any custom hardware, or I would specify what hardware to use. So you mentioned national labs. Is this a product that's available, or is it a prototype that they put together?
It's not even a product. It's just simply a mathematical model, basically, to predict. It's just part of the whole process that we're going to design on the back end of this software. So
okay.
They do not, for example, the National Laboratory of Renewable Energy or Argonne National Lab, they have some predictive model using AI or machine learning, but it's not a product. It's just, they have done some research and published the article, but no product out of it.
Sure. Yeah, so this company here is a company in Colombia. They were monitoring power consumption in a building, turning lights on and off, turning computers on and off. And everything that they do resides, it's mostly a software service. They needed some custom hardware in their case, but everything resides on standard processors. I don't know if you know what a Pico family of processors are, but they're off-the-shelf processors. They wrap them into a pretty package so they can show their IP, but it's not they didn't design custom boards, and specifically because of that, because there's no need to develop custom boards for that. So if you're demonstrating software IP and you can use standard platforms, I would use standard platforms. That's from the guy who gets paid designing custom hardware, just as a side note.
Okay, thank you. And my second question, Cyrus, here is that somewhere in your presentation you mentioned about competitive analysis, which pitch deck we have done, the basic version, but my question is that, in competitive landscape analysis, we could always improve it, but it's very hard to, find all the information about the current products to differentiate ours from the existing products in the market. So I'm not sure to what extent we should try to go ahead and in simple words, have like a simple table showing what features the current products have, what features we are bringing into the market.
Sure. So to that one, the way I will answer it is you're 100% correct. They're not going to share. You'd be surprised how much they're not going to share openly. You'd be surprised how much you will find out if you ask. We've had our customers call competitors directly. We've called our customers competitors and asked questions. No NDAs in place, anything like that, just asking, and if the answer. Also, you have a customer base that you're going to talk to, right? Those customers can tell you what those features are. I would definitely talk to them and ask them. Again, in some cases, they may not be able to share things, but you'd be surprised how much they will share with you. As a caveat, I'm neither a marketer nor a sales guy, so I'm not very good at those two things. My point is, make sure you understand the market. And by the way, if you don't understand that market very well, and you go in front of a potential customer, and if the customer says, oh, well, these other guys also do this, how are you going to differentiate yourself? Understanding those competitors is going to be key. And it's difficult. It's going to take some time. You're not going to find out everything immediately. Does that make sense?
Yes. Unfortunately, by the way, fortunately, the two energy experts that this program has introduced us to them, they're actually very much helping us to answer this question.
Right.
They pretty much know about the industry and certainly help us to find our perfect location to compete.
No, that's great. I was in operation, I think close to 10 years when I found out I had a competitor in town. I'm like, oh my God. And then I learned more about the competitor, and I found out where we're really strong, and found out that they weren't really a direct competitor. But when I speak with potential customers, at least I can have a discussion, an educated discussion, and compare where our strengths are and where we may be better, a better partner for that.
Thank you very much.
Oh, you're welcome. Other questions?
There's one other question in the chat asking about your business model.
Sure.
Or maybe Hamidi wants to maybe clarify a little bit what the question is.
Please.
Yes, hello, Mr. Moghadam. Thank you for the information. It seems like your company is very diversified in many areas.
Yes.
Yes, I just wanted to know basically what your business model is if one wants to have a prototype.
Sure. Absolutely.
Yes.
Sorry. Yeah, so just at a high level, basically, we're a services organization. What we do is we partner with our customers. We also partner with our suppliers. And the way we work is we always meet with the teams that are interested in developing a product to understand what they're trying to develop, understand what their goals are. We always ask the questions I just mentioned, because again, I don't want to take someone's money if they're not ready, if it doesn't make sense. We also want to make sure that we can do what you're looking for. So, the previous discussion on software, we do some software, but we're not a software company. So if someone comes to us with software, we'll probably say no. We had someone come to us on the green tech side. We're doing some separation using a thermochemical separation of hydrogen. And while we could do the work, it wasn't the core of what we do, and it made more sense for them to go somewhere else. Once we had that discussion, we figure out what your requirements are, what the goals are. We have customers that ask us to quote everything all the way to the end. It's difficult to do. We can do that. It tends to be a ROM. But instead, what we try to do is we try to focus on what I had mentioned before, which is, what are you trying to achieve? In the last 17 years, I've had 2 customers total that came to us and said money is no object. So we know everybody's got limited budgets. So what we do is we'll work with you to figure out what you're looking for specifically, what your target is, what your goals are. It would be good to know what your budget is up front. Obviously, we have a lot of customers that come to us asking for help putting together a proposal for SBIR for SBIR funding, and we'll put together a proposal at our cost together for them for whatever their goals are. The proposal is includes our estimates on cost, what the design approach is, what assumptions we've made, what risk areas we're concerned about, maybe questions or other items we would need if the project started. We would rather have time and material efforts. They give us a more flexible, they give us and give you a little bit more flexibility in working on the project, but we've done fixed fee efforts. So say, for example, you came to us and said, I'd like to develop a rack enclosure for Humvee that integrates a cooling system, and we have X dollars. We'll do a fixed fee proposal. The limitation is if they come back to us and they go, well, we wanted 5 more, or we want it to be twice the size, or we wanted to have more cooling, that's a scope change. And then there's this back and forth estimating things. We are flexible. We tailor all the projects. You mentioned the broad range of work that we've done, and that is by choice because we're curious people. We like to work in different industries, and we found that what we've learned in some industries works well in others. So say you came to us tomorrow, I would recommend everyone to put an NDA together. It's not critical, but we think it's a good practice. We'll meet with you, we'll go over all the requirements, we'll develop a proposal, and if it's acceptable, we put together a consulting agreement, and the agreement basically says you own everything. At the end of the project, you'll get everything that we've generated, everything we've created. Our goal ultimately is to get you all the way to production, and then we'll get you a complete technical data package. We'll work with you on supplier selection. We have a bunch of companies we work with that we have a good relationship with, but we also work with other suppliers if you have some. Does that make sense?
Yes, absolutely. Now, because of a number of years of experience that you have, you also can perhaps provide some kind of clue for partnership with other companies as
Correct.
we are producing our own product.
Absolutely. So the most common products that we work with have a combination of mechanicals, electronics. Often they have firmware. So we'll work with contract manufacturers. We have a couple of partners we like to work with in Baltimore. We have suppliers in Asia. A couple of them we really like. But Asian suppliers are a little bit more difficult because of shipping these days and the customs. But yes, at the end, all of this is yours. You get all the quotes, you get everything that we generated in the process.
Yes, great. Thank you.
You're very welcome. Any other questions?
I do. Yeah, I have a question. So if there's a type of machinery that you don't necessarily have in your facility, do you find another company that can outsource that type of work? Like I'm looking at a recycled product, so I would need a particular type of shredder.
Sure.
Do you have those relationships?
We do. So shredder is interesting. We have done some work with shredders, looking for an image we have somewhere. Somewhere we have some printed machine parts, whatever. But yeah, the short of it is yes. So our shop, what you see right here in the middle is an arcade that was designed specifically for one-time development. We made 3 to demonstrate software for that specific customer. That's our shop. In the back, there's a on the left, we've got a CNC. In the back, we've got sheet metal bending and everything else. We have a lot of equipment. The reason we have it is so we can do things quickly, but most of the time we work with suppliers. Say your product, you mentioned shredders. In that case, it would be more a question of selecting a company that makes that more so than, I don't think that there's a lot of companies that just offer shredding as a service, but it's possible. But yes, we would, whatever we don't have, we either have a source for, or we can figure out how to find it.
Okay, thank you.
Other questions?
Quick question.
Sure.
Quick question, Cyrus. Thank you for your time.
Sure.
I was wondering, you also ever take equity position in this startup for the work you do, or is just cash for the service?
That's a good question. So in the 17 years I've been in operation, I've had 2 royalty agreements, 1 promissory note, and 3 equities.
Okay.
So here's the issue with that. They're great. They're basically a big risk, right? They're the same as someone investing cash. Instead, we're investing our sweat equity. The issue with it is that for us, depending on the timing, we may not be very busy on projects, which means we're not getting a lot of cash in-house, which means we have a cash flow problem, which all of you understand very well, can run into some challenges. So the short of it is we've done equity deals. The 2 royalty projects flopped. We learned a lot. It was great projects. We had a lot of fun with it. We spent some money on it. It wasn't horrible, but they both flopped. The promissory note actually worked out great. We did a 5-to-1 investment. We put a certain amount of funds in return for 5-time return if the customer was able to get sales, and they did. So that was great. The 3 equity projects are on hold, are TBD. We'll find out soon if they survive or not. We don't mind doing it. It has to be the right project, the right partner, the right many things.
Okay. A quick second question.
Sure.
I assume the IP during the process, some intellectual property may be coming up and developed there. Who owns that? Is that the person? Okay.
You do. So here's a good example. This Cavala medical diagnostics instrument is a in vitro diagnostics instrument. The design of the cartridge and how the cartridge is operated has 2 patents, maybe 3. I am, as well as a couple of my colleagues at RPM Tech, are noted inventors in the patent, but it's assigned to the customer. They own the IP. As I mentioned, the first thing we do once we agree that there's a project that moves forward, we sign a contract, and that contract specifically says that once all of the bills are paid, you own 100% of the IP, and we don't have any rights to it. And
this time I have one more question, but
sure. Before let me finish that. The one comment I was going to add to this is, for all of you on this call, if you're going to hire any company, whether it's mine or somebody else, if you're going to hire any consultants, and if you're going to hire any employees, make sure that you have well-documented contracts that protect you for the long run. That is something that we do because we want to help you. And we have a very small number of consultants, and all of our employees have all signed IP rights. So you own everything at the end. Go ahead.
There is no question. I do have one more.
Sure, please.
Yeah. Very interesting slide deck you presented, Cyrus. It covered the whole thing from almost from idea all the way to product that can be manufactured. And I saw a lot of steps, and I assume if I understood you right, I take it that you helped the startup company with most of these steps, I assume. You talked about doing IP searches, patentability search.
So we don't do that. So that what's in blue right here, we don't get involved with. We help, but we don't do the actual work when it comes down to the IP search. We get involved with it. So I'll give you an example. We have a customer who came to us. They had a microfluidics cartridge that they wanted to develop. They ran into an issue where their lawyer identified a potential infringing a patent that could be infringed by them. And so they came to us and asked us to figure out how to get around the patent, looking at the claims and whether there was a way we could work around it, because they wanted to achieve the same thing. So that's one. And then the other thing we do is we will help with the patent search on the the quote unquote quick and dirty, a quick search to make sure that we have a basic idea at a high level. But we always recommend lawyers for that. And we don't do marketing and sales.
Okay, so it's fair to say that the RPM tech core competency is building the product and perfecting the design of the product, or even getting a prototype or more advanced product, basically building it, not necessarily on paper, but also in reality. And you have tools and facility that we can, for the first time, a product where you cannot buy the parts from different places, you're able to put them together for the startup, correct?
Correct. So we can do everything that is that's technical design, engineering, and prototyping, fabrication, manufacturing. We are not a manufacturer. We occasionally run large runs of parts, like all of these parts that you see right here. We build about 50 of them for a customer.
Okay, great.
One-time build. We built them because it made sense, and they weren't going to make more after that. But we will help you get to manufacturing. This was one of our old contract manufacturing partners that we worked with.
Okay. And then the startup technical person has to work with you in the facility, or how does that work? You showed something from Denmark.
Yes.
And I assume they came and they had an initial meeting with you. They shared their ideas, their design. And what happened? The technical person goes back to Denmark and you develop it, or he stays in the hotel and come to work every day in your shop?
So that's a good point. So let's go over, this is a good example. And in this case, we were approached by the head of engineering for an organization that makes the material. So Danfoss made this material here. And what they were running into is they didn't have internal skills. So other than this, we started working on a couple of the products first for them. There were demonstration products for actuators and strain sensors. We did everything remotely. I went to Denmark once, and the program manager, engineering manager came to our office twice over a period of 2.5 years. I'm sorry, 4.5 years. We basically had 3 face-to-face meetings. They were looking for specific expertise. When I started this, full disclosure, when I did this project was right at the beginning of RPM Tech, and all of the people that worked on it, except for myself, were consultants. One of those consultants joined full-time since, and we have a team of 20 people. But yeah, so that's why we like to work locally. It's a little bit better. It's a collaborative, setup. The company we're working with here is in Germantown, and every couple of weeks, they may come to our lab and do some testing, and then disappear for maybe 2, 3, 4 weeks and come back. We also go to their offices.
Very good. Thank you very much.
You're very welcome. My expectation is that, again, the people on the call are going to be the system engineers, the chemical engineers, the doctors, the researchers, and very often you will keep core competency in-house. For example, the software company is going to keep the software in-house. It's not going to be outsourced. What we do is we help bring everything together.
Thank you very much.
Absolutely.
Yeah, can I have a question?
Sure, please.
Yes, so I already, my company, I already did all the prototyping, proof of concept. So everything is working, only I do everything through 3D printing. So it's not really fit for manufacturing in large scale, because there's something I don't have experience with, like injection molding and things like that, and outsourcing. So do your company can work with us, convert our prototype into a design that is fit for large scale production?
Yes. So I apologize, I don't have all of the names, but a little earlier, a lady asked about how we work. What we'll do in a case of like yours, and you're not the only one, we'll meet with you. We'll figure out exactly, what you're trying to achieve with your prototype to production, right? If you come to us and say, I'd like to make 2,000 or 3,000 a year, it may change the scope of the effort compared to 20,000 a year or $1 million a year. And the other thing that may also impact this is what the cost target is. But yes, we'll call this the design for manufacturability phase. And what we'll do is we'll work with you to make sure we understand the requirements. And then what we'll do is we'll convert your design. Is it an all mechanical design or does it include electronics?
No, it's mostly mechanical design, like just fish tank filters mostly.
Yeah, that's right.
So that part also is just like, for example, like can you, for example, if we show you, like if I show you the prototypes and can you do an estimate how much it costs for us to work with you for on the project? Because well, right now it's just I don't have the fund yet, but I would love to do that as soon as I get any funding.
Sure. Yeah, absolutely. So in your case, what we'll do is we'll sit down with you. We'll look at the part. We'll ask you some questions related to what can we do with the part in terms of slight changes to the shape potentially for manufacturability, draft angles, wall thicknesses, and so on. We'll figure out what material requirements there may be in terms of safety in the water and everything else, put together an estimate, and then whenever you're ready, we can work with you on that. We can also help you with the process of selecting suppliers, as well as deciding if you want to manufacture in the US, in Mexico, and in China, depending on partly the cost that you're willing to pay for the tools and the parts. Typically, I tell people, the cost of plastic parts these days, injection molded in the US, is probably 50% more than in China. There was a point where it was 4 or 5 times, but between the shipping costs and the amount of automation that's been added in the injection molded, injection molding companies in the US, it's much faster. Tool cost is 2 to 2.5, sometimes 3 times more expensive.
Yeah, so the first part is just like consulting. Like you look at our design and see what you can do and what you need from us. That part, like, does it cost me, like, depending on the time working with you, or it will be just cost free?
So the proposal is free. We'll do the proposal, and then we'll tell you how much it's going to cost in that proposal.
Very great. Sound like I can work with you. So yeah, I will contact you later.
I'd love to. I did put my contact information. And by the way, if I can't help, if my company can't help, we'll figure out who can help you. There's a lot of people out there that have skills and capabilities. Someone approached me not too long ago through, I think, University of Maryland. They were looking for us to machine some parts. I just gave them our machinist, our favorite machine shop in Maryland. I would give them their contact information, and they went straight to them. There's no need for us. We don't want to add cost to your product.
Yes, great. Because there's some parts right now I just see because I'm prototyping it myself, and so I have to buy things off the shelf. And I'm sure that if we do mass production, we can reduce the cost. Integrated that part into the product. So yeah, all of that I will want to work with some company like yours. So yeah, I definitely will contact you later.
Certainly, no a problem. Look forward to it.
Okay, thank you.
You're welcome. Other questions?
I know we're at the hour. I did see Sina's hand one more time. I don't know, Sina, do you have a quick question before we end this?
Yes. So you mentioned that we should be careful with any type of contract that we is going to have with any consultant or any other team. So other than IP, is there any other long-term issue that we should take into consideration when we design a contract?
Yeah, the most important one is IP, and IP is, for me, is very general, right? It's not just a patent, it's everything that's generated. So as long as you have a good a document that says, all of the code, the native files, the drawings, the anything that is created in the process you own, you're covered. Again, this is a concern where I had a company come to me, ask me to reverse engineer a product that they had paid development for. And because they didn't have an agreement with the company, we had to go back and regenerate all of the files from scratch instead of taking them and modifying them.
Thank you.
You're welcome. I will invite anyone who's interested. We're in Harford County, next to Bel Air, just north of Baltimore. I'd love to give a tour and show you what we do. And if you have any questions, please reach out, and love to help you. And if we can help you, we'll put together a proposal.
So yeah, before I leave this call, just make sure you go in the chat and copy Cyrus's email and LinkedIn. But this has been a great discussion, and I appreciate your time, Cyrus, or we all appreciate your time. So thank you everyone. And thank you, Cyrus, for all that in really detailed and informative information.